So the problem says that a block of mass 5 kg is pulled along a horizontal frictionless surface by a cord that exerts a force of F is equal to 12 Newton at an angle of 25 degrees. So here is a diagram. So this is the mass of M, which is 5 kg, and this is the surface is frictionless, and the force is acting in that direction, but the mass is pulled in that manner with the force, and with the horizontal the force makes an angle of 25 degree. So these are the information that we are given, and then the first part is what is the magnitude of the block's acceleration, at what magnitude will it accelerate. So the force is F, but it is the horizontal component of the force will act in the pulling, so that is F cos theta, that's the horizontal component. That one will be equal to ma, which is the acceleration. So that is the force that is doing the pulling work, and since it is frictionless, there is no friction force. So F will be the pulling work is done by this component. So this one divided by M will be A. So that's 12, and then cos of 25 degree divided by 5, and we get 2.18 meter per second square. So that's the acceleration. Then the second part is if the force magnitude is slowly increased here, if the force magnitude is slowly increased, what's the value just before the block is completely lifted off the surface. So the force magnitude is increasing, the magnitude, and as a result there will be a point when the object will be lifted, totally lifted from the surface, so it will go upwards. And when that's happening, this is the force that is acting in the force direction, and this is the horizontal component, which is F cos theta, as we saw before, is cos 25 degree, and the vertical component will be F sin 25 degree, and that vertical component will be equal to the weight of the object. When the object it has to be just equal to the weight, or just a little bit more than the weight, when the object will be lifted off the surface. So F sin 25 degree, this is a new F, this is not our 12 because F is increasing. Let's call it F1. F1 sin 25 degree, when the F is increased, we need to find this F1 actually. So F1 sin 25 degree will be equal to mg, and this is the case, this is the situation when the object is totally lifted off the surface. The vertical component will be doing the lifting up work, because it will act against the weight of the object. So now we have to find F1, that will be mg. M is 5, this is 9.8, and this is just sine 25 degree, and we get approximately 116 Newton. I hope the calculation is correct, but please double check. So that's there. And finally there is a third part which says what is the value of the block's acceleration when it is completely lifted off the surface. So we are assuming that actually the force has to be just a little above that when it's completely lifted off, and we have to calculate what is the value of the acceleration when it is being lifted up. So again, the acceleration is in this direction, so that will be equal to F1 now F1 we know, and F1 cos 25 degree will be equal to m, and this is new acceleration, let's call it m1 maybe. So this is the situation when the force when the object is lifted off the ground, and exactly at that time what is the acceleration, that's what we are trying to calculate. So we will use F1 as 116 because we calculated at what force, above what force, or just at what force when the object is being lifted up from the surface, lifted off the surface. So A1 will be, this is 116 cosine of 25 degree, and this is again 5, so this is multiplication. 116 is the magnitude of the force. When we do that, it is 21 meter per second square, so this is a much higher value of acceleration. Initially, when our 12 Newton force was working, the acceleration was 2.18. I think I did it here. And then when the force was slowly increased, there was a point which is much higher, 116 Newton value of force, when the object will be lifted off the surface completely, and at that time the acceleration is 21 meter per second square.